Hey everybody, this is probably going to be the last math video of the year. And it's the last lesson in this series of lessons. It's labeled number 5 for you. And it's about this topic called dilations. So I'm going to go through some keywords and then I'm going to take you on to the buzz math questions and I'm going to go through it that way because I think it's maybe the most relevant for you. So a dilation is taking a picture on a graph in these examples is taking a picture on a graph and either making it bigger or smaller, but the shape doesn't change. Okay, so it's not necessarily the same size, but it still looks the same. It's just been enlarged or reduced. Okay, so actually that's those two words right here, enlargement and reduction, the two keywords. Their enlargement is to make bigger, and reduction is to shrink down and make smaller. Okay, so that's those two. Scale factor means if you look at this first part here, it says scale factor of 2. That would mean that everything is double. It's become twice as big, so the scale factor is multiplied by 2. Maybe it's 0.5, so then everything would become half as big, or 0.5 times the size. Okay, so the scale factor is how much bigger or smaller it becomes. And this word dilation just means to make bigger or smaller. You're going to see that on the Buzz Math page number 1. They give a definition there. So we're going to work through some Buzz Math questions. Most of the stuff in questions 1 to 6. That's what I definitely want you to do. Questions 7 to 10 are a little trickier, and I don't want to spend too much time on this video, so you're going to have to do those as extension if you want. But what I'm definitely looking for is questions 1 to 6. Okay, so I'll share the link actually with you to this Buzz Math so that you have it open as you're working through. You can flip between the Edpuzzle and the Buzz Math. Okay, so a dilation is something that produces a transformation that produces an image. So it changes the shape. It's the same shape, but it's not the same size. So if we look at this example, if I were to enlarge it, okay, it's getting bigger and all of these are, doubling in size. And if I shrink it down, they're becoming half, just for an example. Okay, so these are all dilations. I'll let you finish the rest of the questions here on your own because they're not so bad. So on page 2, it's just loading a bit. We're always going to be using the middle as our center point, and then we're going to enlarge from there. Okay, so it's asking us what are the coordinates of the orange rectangle on the outside. So originally we went from here over to here, and you'll notice that this coordinate is at -5. Let's see, -5 here, and 3. And then this coordinate is at -10 and 6. So all we need to do down here is write with brackets -10, 6. Okay, and you can do that for the rest of them. Your question will be different, but you're just labeling the coordinates of each corner of the orange rectangle, if that's the shape that you have. Okay? And maybe you'll notice a pattern between the coordinates here and the coordinates here. This was at -5 and this moved to -10, so it's been multiplied by 2. I think that's in part B for this, but you'll get to that. Okay, so that's question 2. Question 3, if it loads there, okay. So question 3 is, what is the scale factor in this example? So when we have a number in front of our x coordinate, that's going to be the scale factor. So all of my x coordinates became 2 multiplied by whatever it was. So in this example, it's going to be a scale factor of 2. Okay, and then if we change all of these coordinates, here they're asking to do a scale factor of 3. So all of these coordinates are going to be multiplied by 3. So if we have 2 and 1 as the first coordinate. Okay, that's down here, 2 and 1. If we multiply each coordinate by 3, it's going to be at 6 and 3. So I can go right ahead and move that down here to 6 and 3. Okay, and the coordinate for B and the coordinate for C are also going to be changed because this shape is going to be 3 times as big. The enlargement is going to be by multiplying by 3. So this coordinate is at 2 and 4, so it's going to move 2 times 3 is 6, so it's going to move up to 6. It's here, okay? And 4 times 3 is 12, so it needs to be up here, okay? Another way you could do it is count these squares, 1, 2, and 3 squares, and we multiply the length of this side by 3. So 3 times 3 is 9, so this length should be 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep, which is correct. Okay, this coordinate is at 6 here and 1. So if we multiply by 3, 6 times 3 is 18. So we need to move over here to 18, and we're still on 3 because we went 1 times 3. So the enlarged version, this is 3 times as big as this picture. And we can check to see if it's right. Okay. So just for an example, hopefully yours are similar and it's easy enough to follow along with me. This is probably the hardest question. It's also asking to multiply by 3, but we've got this really strange scale. So the orange rectangle, or the orange square, is going to be 3 times as big, and the blue square is going to be a third as big. So we're going to divide by 3. So first, maybe let's start by looking at the coordinates right here at Z. So I might use it's a bit slow on here. Use the pencil tool. Okay. So we're going to start by looking at this coordinate here. It's at 18 and 18. Okay. And I'm just going to write that down. Okay, so that's 18 there and 18 over here. Doesn't really like the drawing part. Okay, so this coordinate is at 18 and 18. So we need to make our new coordinate at 18, but times by 3. So 18 times 3. You can do it on the calculator if you're struggling. I don't know why it's gone away here. Remember that there is a calculator in the corner here. So 54 on this one is here between 48 and 60. Okay, so we're going to have our first coordinate over here at 54. Okay, this isn't where these other ones are going. I'm just moving them over for now. Okay, now another way you could do this part, instead of using coordinates for the next phase, is to count these squares here. 1, 2, 3, 4, 5, 6. So this side is 6 long. It needs to be 6 times by 3 for the orange version. So it really needs to be 18 squares long. So we need to count 18 squares, which is going to take a second. So 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Oh my gosh, it's almost off my page. So it's up here at just above 156. What's that? 160, 162? Yeah. Okay, so that's where the one side goes. This one also needs to be 18, so we have to count 18 across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, so it's going to be over here, I think, if I've counted correctly. This is probably the hardest part, is counting these sides. So now this is 3 times as big. Each side is 18 because originally it was 6, and we're multiplying by 3. So I think if I've counted correctly, I might not. It looks more like a rectangle to me, but we'll mark it quickly and see. And then for this one, instead of being 6 long, it's going to be 6 divided by 3, which is 2. So it's just going to be a 2 by 2 square. And instead of being here at 18, it's going to start at 18 divided by 3, which is 6. So this one is a little quicker to draw, like that. Okay, so we took the original coordinate divided by 3, and that gave me the new location of the start. And now I just take the side length and divide by 3. And maybe we're right. Let's find out. Oh, it's wrong. I probably drew this orange one. But you can always look at your answers if you want to see. Okay? So be careful counting. I was doing it quickly. But yeah, that's probably why it's wrong. Okay? If we have a scale factor greater than 1, okay, that results in an enlargement. It's going to make something bigger. But if we have something between 0 and 1, it's going to be a reduction. It's going to shrink it down. Okay? So hopefully that question isn't too bad for you. And I think we're on to number 5. Okay, so 5 is another example with a triangle. Okay, and they're asking you to say what's happening here from the gray one to the orange one. So the transformation is a reduction. Okay, it's a dilation that shows a reduction of the pre-image. Okay, so it's shrinking in all sides to a smaller orange one. And every coordinate in the pre-image is multiplied by 2, multiplied by a half, or moved 2 units to the right. I'm going to leave this one for you guys to think about on BuzzMath and show you in 2 seconds. Okay, so this is multiplied by a half because it's shrinking down. The number has to be between 0 and 1. Okay? And if we're writing this out, both the x and the y coordinates right here are multiplied by a half. So that's how we would represent it in this particular example. Your examples might be different, but they'll be similar, okay? And the last page, the rest of them after page 6, 7, 8, 9, and 10 are going to be for bonus, kind of extension work. You can definitely do them, but it just might take a bit of perseverance in your part, okay? So looking at this one, they're asking us what is the scale factor. So here, this is at -5 and 4. And, oh, sorry, this goes up. So, see, look, I made a mistake. This scale goes up by 2. So this is actually at -6 and 4. Yeah. Okay. So -6 moved to -12, and 4 moved up to 8. So if you can think about -6 to -12 is just multiplying by 2. So this scale factor is a scale factor of 2. Right? And you can just put it into BuzzMath like that. Okay, here, this is the bigger, black one is the main one, and then the orange one is the reduction. It's been shrunken down. I will leave this for you guys to figure out, but if you look at this coordinate, -36 and what's that, 20, hold on, we're going up by 3 now, so it's at 27, okay? So -36 and 27 became -12 and 9. Okay, so we have a scale factor of 1/3 because 36 divided by 3 is -12. Well, -36 divided by 3 is -12. And same with 27 divided by 3 gives me 9. Okay? All right, I'll leave you with that. I'm sure this video is a little bit longer than normal, but I wanted to make sure that you guys had enough help. And please schedule a time with me to review your final project. Okay, that'll happen next week. You'll get some information coming out about that. But I do want to meet individually with everybody just to chat for 5 or 10 minutes about our expectations, and then probably say goodbye to you for the school year too. But we'll see. Okay, thank you very much, and hopefully see you soon.